Sweet. All right, how are you guys doing today?
Good.
Perfect. How was lunch? Sweet. Well, thank you guys so much for coming out to my talk. I didn't know identity and authentication was that interesting, but welcome. I hope you guys learned something new. My talk today is titled A Non-Dystopian Look at Modern Authentication. And the reason I titled it this was because if you're implementing modern identity solutions for your single page applications, for your regular web apps, and you're trying to implement some of the newer standards, OAuth, OpenID Connect, it can get really confusing really quick. And today I hope to kind of, dispel some of those complexities and kind of make it a little bit easier to understand what's going on with modern authentication and how it can actually benefit your applications. So just a bit about me. My name is Kukic. I work as a developer evangelist for a company called Auth0. Are any of you guys familiar with Auth0? Okay, awesome. So a couple of you guys. For those of you guys that are not familiar, Auth0 is it's an identity platform, a universal identity platform that handles authentication and authorization for any type of application, whether it's mobile, web app, single page application, API. So that's enough about Auth0. I am also a Google developer expert for web technologies, so that's why I'm at this conference. So I want to start this talk off with a statement that authentication used to be easy. And not really, right? So, if you were building authentication systems, login systems, back in the day, whether it's 10 or 15 years ago, it was much simpler. There wasn't as many things to consider, as many things to think about, delegation and all of these different instances. So it was much easier to conceptualize, much easier to implement, and much easier to maintain. And if we look at it, we really just had one backend server that was fully secured. We could manage it, maintain it ourselves, and our users typically came to us via the browser. So whether it was Chrome or Internet Explorer, Firefox, they would come, make a request to our application. Our backend server would look at this request, decide whether it wanted to fulfill it or not, render all of that HTML on the backend, and then present it to the browser and to the user. So securing this was much easier because if we wanted to have user authentication and identity management, we would collect the user's authentication credentials, their username and password, or their email and password, send them directly to our backend server. Our backend server would validate these credentials, make sure the user is who they say they are. If they were, the server would say, okay, great, you are logged in. Here is a cookie that has a session identifier. And in this instance, our session ID is 123. So now our browser knows how to identify our user. So when we wanted to access a protected resource, we had this session cookie. We go to a protected resource like an account page or a store checkout page. That cookie gets sent. Our backend server says, hey, I have the session 123. Is this an active session in the database? Yes, it is. Okay, great. Here's your HTML content. And you are who you say you are. So in that instance, it's much easier to conceptualize and see what's going on and how authentication works. But modern auth is a lot more complex. It's a lot more difficult to grasp, to conceptualize, and to implement. So, some phrases or terms you might have heard of, grant types, authentication flows, scopes, et cetera, et cetera. There's all of these different keywords, key phrases, terms just kind of floating around and trying to figure out what means what, how it should work, and what it means can be a really, really difficult thing. So today what I wanted to look at was 4 types of authentication and how our modern standards like OAuth and OpenID Connect work and integrate into these types of applications. So we're going to look at a traditional web-based application. So if you're building a Laravel application, for example, or a Node Express application, and you were still serving all of your HTML server-side, rendering it, and then pushing it to the browser. We're going to look at API authentication. So if you have an API that needs to talk to a different API, how do you secure that communication? We're going to look at single-page app applications. So If you are building an Angular or a React or a Vue.js application, how do you handle identity user management without having a backend server? And then finally, we're going to take a brief look at native applications, and whether that's a desktop application, an iOS or Android app, or a Chrome extension, for example. We're going to look at those types of apps. But before we get into that, let's kind of set some ground rules, set some basic understanding of the concepts that we're going to be talking about. And the first one is OAuth 2.0. Now, how many of you guys are familiar with OAuth 2.0? Awesome. How many of you guys have implemented OAuth 2.0 in the past? Okay, so a fair number of you. For those of you guys that haven't, a simple definition of OAuth 2 is it is an open standard for access delegation commonly used as a way for internet users to grant websites or applications access to their information on other websites, but without giving them the passwords. Now, that's a very long-winded definition that can really be summed up and summarized as an open standard for access delegation. So really what OAuth allows us to do is to delegate some access from one application to a different application. And the reason I started with OAuth 2.0 is because the authentication framework that we're going to be talking about today is called OpenID Connect. And that is an authentication layer built on top of OAuth 2.0, which allows clients to basically verify user identities and pass user information from one application to another, or from an authorization server to your application. So it's kind of a who came first, chicken or the egg scenario, where OAuth 2.0 is a delegation standard where it doesn't have anything to do with authentication, isn't concerned with authentication, but is required to exist and to be implemented before you can implement user authentication. So the next thing we're going to look at is OAuth 2.0 roles and understand kind of the players in the OAuth space and how they work and integrate with each other. And there are really 4 roles that we're going to be looking at today. The first one is the resource owner. And the resource owner is the entity that can grant access to a protected resource. And this is typically the end user. This is the person that is authenticating, the user that's logging in. So if you think of the resource owner as you, the person who is logging in, you're pretty much good to go. Next, we have the resource server, and this is the server hosting the protected resource. So this is typically the API that you want to access, or that the user wants to access. And this can be your API, this could be a third-party API that you're integrating into, but this is basically the server that contains protected data that you're protecting. Next, we have the client, which is the app requesting access to a protected resource on behalf of the resource owner. So the resource owner, you as a user, you can give access, but you as an individual cannot, I can't just yell at Facebook and say, show me my pictures. I have to use a client, and whether that's, Facebook.com or the mobile app, or some type of different other application, I'm using a client. So the client is the application, your web app, your mobile app, that talks to the API on your or the resource owner's behalf. And then finally, we have the authorization server. And the authorization server is the server that authenticates the resource owner and issues tokens. So the authorization server's job is to verify the user credentials, make sure that the user is logged in, and also tell the application, tell the client, and tell the resource server that, yes, this person's logged in, this is what they can do, and these are their roles and permissions. And really, when we talk about the authorization server, we're just talking about a couple of different endpoints. We're not talking about necessarily a physical server or something that has to be totally separate from your other infrastructure, but in some instances it can be. But when we talk about the authorization server, we're really talking about the OAuth 2 endpoints that deal with user authentication and delegation. And there are only 2 of those, so it's much simpler here. We have the authorization endpoint, which is used to interact with the resource owner and get the authorization to access the protected resources. So really what this means is you hit this endpoint, you send it the user credentials, the user login, username and password, their social connection information. Basically, the authorization server verifies and identifies who the user is. And then we also have the token endpoint, which is used by the application in order to get an access token or a refresh token or any type of information about the user. So really with just these two endpoints, /authorization, /token, you can get your own OAuth 2.0 server up and running. Next, I kind of mentioned access tokens, refresh tokens, but you're going to be hearing about some other concepts as well, like the authorization code and the ID token. So what the heck did these mean? How did they work? What are they? So let's really briefly define these before we get into our use case scenarios. So the first one, and the most common one, is probably the authorization code. And this is really just an opaque string meant to exchange with an access token at the token endpoint. So what this means is this is just a random string of characters. It could be 10 characters, it could be 60 characters. It's just a random string that doesn't mean anything to you as an end user. It doesn't mean anything to your application. All it does is once you have this authorization code, you send it to that authorization server. The authorization server looks at that content, and if it figures out that yes, this is a valid authorization code, it's going to issue some tokens or some information about your users. Access tokens are an opaque string or a JSON Web Token that denotes who has authorized which permissions or scopes to which application. So when we talk about an access token, in most instances, this is a JSON Web Token that contains information about the user, about the user's about who the user is, who they logged in, what access, what permissions they have. And this is what you're going to be using with your resource server to kind of identify who the user is and decide whether to serve resources or not. A refresh token is a special kind of token that contains the information required to obtain a new access token or ID token. And where refresh tokens come into play, and these can also be JSON Web Tokens, they can be opaque strings that don't mean anything to the end user. But refresh tokens allow you to, instead of sending your credentials again to re-identify yourself, just send this refresh token and you'll automatically get a new access token or a new ID token. So they allow you to kind of extend your session and stay logged in much longer than you would normally be. And then finally, we have the ID token, which is a JSON Web Token in almost all instances. And it contains user profile information, such as the user's name, email, demographic information, and really any other information you wanted to keep on your user. And this is represented in the form of claims. So this is just you can think of it as just a JSON object that has a bunch of different properties like first name, last name, email address, and so on and so forth. So these are the four types of codes and tokens that we're going to be referencing in the rest of our talk. And then we have the OAuth 2.0 flows, which dictate how an application is authenticated and how you get information from the authorization server to your application. And depending on the type of application you're building, if it's a web app, or if it's a single-page application, you're going to be required to use a different flow. And the four flows we're going to look at are the authorization code flow, the authorization code with proof key for code exchange, which is typically used in desktop applications and mobile applications, the implicit flow, which is only used in single-page applications, and the client credentials grant flow, which is used in API-to-API communications. So with that brief crash course into OAuth, I know you might be a little confused by now. I know I threw a lot of terms out at you, but we're going to go into scenarios now and see how these flows actually work and how they get implemented and integrated into our applications. So the first one we're going to look at is a traditional web application that uses the authorization code flow. So to establish our baseline application, something that we're probably all familiar with, we have our backend server, and this can be any language, any technology, whether it's PHP or Node or ASP.NET. Our backend, it takes care of rendering the user experience. It takes care of the data access layer, and then we have our browser that accesses the user information, so that actually displays what our server is sending back. So we make requests to our backend server. Our backend server responds with pre-rendered HTML, and everything works good. When we want to authenticate this application in this new modern OAuth scenario, the way it's going to work is we're going to introduce the authorization server. And this authorization server, it could be a third party such as Auth0 or Okta or AWS Cognito or any other third party that you didn't build yourself, or it could be your own authorization server that you set up to handle your user identities. The flow works exactly the same. And basically the way it works is when the user clicks on the login button in their browser for your application, they're going to be redirected to the authorization server login page. A login page is going to be displayed. It might be on a subdomain. So, a really good example that I always use is Google. So when you go to log into Gmail, for example, instead of logging in and providing your credentials at gmail.com, you get redirected to accounts.google.com. You put in your email and password, and then you have access to Gmail, to Drive, to YouTube, to all of Google services. And the same thing works with Microsoft, and many other companies are kind of moving to this approach of having a universal single hosted login page. And the reason for this is, you really don't want to trust your application, whether it's a web application or a single page application, to collect user credentials, to collect user emails, passwords. And the reason for that is, you have so much code in your application. Just to pick on Angular, for example, or if you're building a single page application, you have to pull in from npm Angular, and then you have all of the other node modules that get pulled in with that, and then more and more node modules. If you ever try to delete that file, it's like 700,000 files, and you really can't go and validate each line of that code to make sure that there isn't something malicious in there. And there's been a bunch of different articles that came out over the last year that bad code was pushed to npm packages that was malicious, that was capturing user emails, that was capturing user credentials and sending them to third-party domains and sending them somewhere bad. And even popular libraries had different levels of malware and infections. So having this centralized hosted login page that all it does is, it's very minimal, all it does is collect user emails and passwords, sends them securely over HTTPS to a backend, really mitigates a lot of those risks for you. So the user goes to this hosted login page, they provide their username and password credentials, and now what the authorization server does is, instead of saying, okay, this user's logged in, it says, okay, I think this user's logged in, but I'm going to go back into your application to this special route called callback, and you can name this whatever you want, but typically it's a callback route because you're calling back into your application, and it's going to pass a query string parameter called code, which is going to have that authorization code opaque string. Now, since we're building a traditional web application, the browser doesn't really do anything here. All it does is it passes this code to the backend. It says, hey, the callback route was called. Here's this query string parameter with the code 123. Now what our backend is going to do is say, hey, okay, you called the callback. You have a valid looking code. Let's verify it. So it's going to take this code and go back to the authorization server and say, hey, this user is trying to log in. They gave me this code. Is this a valid authorization code from the server? Is this a good request? And since it is, the user was properly authenticated, the code came from the authorization server. The authorization server is going to say, yes, this user is logged in, they are who they say they are, and here are the tokens you requested. Here's an access token. Yes?
So there are two calls to the authorization server?
Yes. Yes, so you have the initial call to provide your user credentials, and then you have the secondary call to provide the authorization code. So once that is done, we get our access token, we get our potentially refresh token, our ID token in the backend. At this point, our traditional web app server is going to say, okay, this user is logged in. What I'm going to do is set that traditional cookie saying, here's this user. I'm going to set their session ID to 123, and now I know who they are. So now that the user is authenticated, they have a cookie in their browser. Whenever they go and try to access a protected resource, that cookie automatically gets sent. The backend server verifies that the cookie is still valid, the session ID is valid, and if it is, it serves the HTML back, and everything works as you would expect it to. At this point, we have no more interaction with the authorization server. The authorization server, doesn't care what happens from this point on until you go to make a change to your user. So say you wanted to make a change, the user wanted to change their email address or their password or some type of credentials. What we would do here is we're still talking to our backend server, and we say, hey, I want to change my profile information and change my email from auto@gmail.com to auto2@gmail.com. We send that request to our backend server saying, I want to make this change. And now, since we're no longer maintaining our user in our traditional web app application, we're going to kind of query that request to our authorization server and say, hey, I would like to change this user's email or password in this instance. And here's this access token you gave me earlier so that I can talk to the authorization server or my user management store and change that information. The authorization server is going to verify that the token is correct. That's why we got the tokens earlier. If it is correct, it's going to come back and say OK. And we can kind of send a success message back to the user's browser saying, yes, you are who you say you are logged in, and everything works great. So that is the kind of traditional web application in the OAuth OpenID Connect world. Before we move on, any questions? Yes?
So in this case, is the backend server actually sending the new password to the other server?
Yes.
Why doesn't the front end call for the change password instead of the back end?
So the front end doesn't call it because the front end doesn't have the access token, so it doesn't have any authentication information regarding the authorization server. So it just has that session identifier that helps it talk to the back end, but it can't talk to any other application in this instance.
That's so you don't expose the token so that they couldn't hack it?
Yeah.
But normally you wouldn't have that functionality on the backend server. It would be on the identity provider.
It would be on the...
Oh, okay.
Yep. Cool. So, and then I'll try to wrap up a little bit earlier so we'll have more time for questions. But next, let's take a look at how we would secure a backend application. So this is basically your API talking to a different API, or if you wanted to build an application that you wanted to expose your API to other companies to utilize, how would you secure that communication to make sure you can track who's using the API, revoke access if they're abusing it, track metrics so you can charge them for it, and so on and so forth. So the API to API, or what we at Auth0 call it, is a machine-to-machine communication. It uses the client credentials grant flow. And to establish our baseline here, you have an API that you want to talk to. So, for my example, let's use the weather.com API, and you're building an application that is trying to utilize the weather.com API so that you can present that information in your own weather application. And I'm just using weather because it is freezing in Chicago, and I'm from Vegas, and it is so cold. So, our baseline here, if you were talking to an unsecured API, you, from your application, could just make a request, an HTTP request or an HTTPS request to the API saying, hey, give me the temperatures for zip code 89166. And the other API would process that and send you JSON back, or it could be XML, it could be a different format, but it's most typically, we're working with REST-based APIs that send JSON back and forth. So it would send you back a HTTP response that had the JSON body, and you could get those temperatures and display them to the users. So how do we handle authentication in this case where we don't normally have users? We don't have somebody to actually put in their username and password credentials. So again, we're going to have the concept of an authorization server, or those series of endpoints that help us authenticate and identify who the user is. And at this point, we're going to have this authorization server is actually the authorization server that works with this API right here. And before our API can talk to this API in a secure manner, it's going to need to get a series of keys from the initial API that it's trying to talk to. And a good real-world example of this is, for example, if you wanted to build an application using Facebook's graph, you would sign up at developers.facebook.com, you would create your application, and they would issue you a client secret and a client ID. Or if you're building a GitHub application that uses the GitHub API, same thing. You sign up at developers.github, you get a client secret, client ID, and you're going to be using these to talk to the API. So your application is going to get the client secret and the client ID in the application, and before it can make a request to the API, it's going to go to the authorization server and say, hey, I have this client ID and I have this client secret, and I would like to be authenticated so that I can access the protected resources. The authorization server is going to look at those credentials, look at the client ID, look at the secret. If it is correct, if it is still valid and not revoked, it's going to issue you an access token, a JSON Web Token or an opaque string that helps you talk to the weather API. So now that you're authenticated, you have an access token in your application. Your API doesn't have to talk to the authorization server. And when it wants to access the protected resources of the weather.com API, it just makes an HTTPS request, with some JSON data that might be like a zip code or an address, and it attaches that access token to the request, typically in an authorization header or in a query string parameter, or however else it can do it. The weather.com API, the API that we're accessing, is going to look at that JSON Web Token, look at that access token, decode it, and verify that it's still an active access token. And if it is, and if you have the permission to get the weather for 89166, it's going to send you back a JSON response with the temperatures for that area. Now, that works great and all, but the current best practice for access tokens is that they should only be valid for a limited amount of time, and that there's no strong guidance on how long it should be. It could be 10 minutes, it could be 2 hours, it could be a day, but the idea is that these access tokens should expire fairly frequently, so that if in the event the access token gets stolen or leaked, it's very hard to revoke. You can't revoke a token, but you can blacklist it until it's expired, and that's a whole another topic for another day. But basically, your access tokens should really be short-lived and only used for a limited amount of time. And this is where refresh tokens come in. So instead of your application sending the credentials, so if you wanted to use refresh tokens, which are long-lived opaque tokens that can only be used by your application, your API, to get another access token, if you wanted to utilize those in your application, when you authenticate with the client credentials grant flow, you pass in that client ID and client secret. You can request, in addition to the access token, also a refresh token. So now when you have this refresh token, you can kind of store it in your APIs, either in a database or an in-memory store. But basically, you just have this access or this refresh token somewhere in your application. And when your access token is expired, whether that was after an hour or 2 hours or however long it was, to get a new access token, all you have to do is go to the authorization server and say, hey, I have this refresh token. It is 12345. I would like a new access token. The refresh token is going to be sent to the authorization server. The authorization server is going to say, hey, is this a valid refresh token? Yes, it is. Okay, this client requested a new access token, so I'm going to give them a new one. It's going to issue it. So now we have a valid access token, and we can go ahead and talk to our weather.com API and get our responses just like we normally would. Okay, so that's all the slides there. Do we have any questions for API to API communication? Yes?
So the server side, does it talk to the auth server at all?
In this example, it does not. So the way that our weather.com API server knows whether to serve the request or not is that access token. So it's going to have some type of middleware that's going to check and see if the token is valid, and it's going to have some information from the authorization server, but it's not going to have to go and ask the authorization server, is this a valid access token? And usually the way that's done is we verify the integrity of an access token through the token signature. So in a JSON Web Token, you have the header that tells you what type of token it is, the body that tells you, all the claims and permissions for what an access token can do, and then the last part is a cryptographic signature that can be verified by the server here. And if and the way that we can verify those is when our authorization server issues the token and creates it, it's going to sign it with the cryptographic key, and it could be like HS256, which uses a string-based password, or it could be RS256, which uses a public-private key encryption. So basically signs it with the private key. We give the API server a public key that can verify the integrity of the token, and it just works. So the next application that we have is a single page application. And single page applications are unique in that they require the use of the implicit grant flow. And this has been true up until December of last year, where the OpenID and the OAuth working group came out with a new best current practices document that said that you shouldn't use the implicit grant flow because it has a lot of flaws. And all single page applications these days still use this grant flow. So I'm going to cover it here, but then I'll also cover why you might not want to use the implicit grant flow and what the alternative to it is. But to establish our baseline, you have a server, and this could be living at api.myapp.com, and all it does is send back RESTful HTTPS responses, and it just takes in JSON data and sends out JSON data. And then you have your single page application that lives entirely in the browser. Now this could be a Vue application, it could be an Angular application, a React application, or your own custom JavaScript framework. So you just make HTTP requests to your API sends back JSON, and your single page application decides what to do with that JSON as far as which page to render, what experience to give to the user. And in our authentication scenario here, again, we have that authorization server. A user when they click on the login page, they get redirected to that universal login page where they provide their credentials, and whether that's username and password or a social login or single sign-on if they have it enabled, they get authenticated. And once they are authenticated on the authorization server, what the server is going to do in that callback is it's just going to say, okay, you're authenticated. Here is your access token, and here is your ID token, and you're good to go. So you're authenticated. Your single page application has the access token and the ID token stored client side, and now it can make requests. With every request it makes to the backend server, it attaches the access token. The access token gets verified on the backend. If it's still valid, if it has the right permissions, the user gets the protected data that they were trying to do. But the issue arises where you have this access token. The ID token really doesn't allow you any elevated access. So, having the ID token in the browser is, typically fine. It doesn't pose too many risks. But having that access token in the browser is kind of a problem, because if a malicious party were to be able to get in your application and steal that access token, they can impersonate your user and use that token on their behalf and do some really nasty things. So the best current practices for that is to not store the access token in the browser. So you can't store it in local storage, you can't store it in a cookie, you can't store it in session storage, but So the only place where you can store it is in memory. So when you get that token, you store it in like an NGRX store, or you just kind of store it in a global variable so you can access it. And when the page is refreshed or the user opens up your app in a new tab, that in-memory database gets kind of wiped, and now they don't have the access token anymore, and they have to re-authenticate. Well, that would be a really crappy experience if every single time your user refreshed their page, they had to re-authenticate to access your application, and nobody would use your app. So how do we get around that? The answer is silent authentication. And basically the way that this works is when the user goes to authenticate, they put in their login and password credentials, they get authenticated. Before we make that callback and give them the access token and the ID token, we set a session cookie identifier, basically, like we would in a traditional web application, in our authorization server saying, hey, this user is logged in, and then we issue those tokens so that the user can make the request. The user has the tokens and they can make their request just fine. But when they refresh the page, they are logged out. So by default, they are logged out. They no longer have that access token, that ID token. And since that cookie, that session ID, is stored on a different third-party domain, they don't have access to that cookie. So they can't say, so we can't say, hey, you are logged in, and let's keep the party going. But what we can do is, from our single-page application, we can make a request in an iframe that goes to our authorization server and says, hey, load up this page, and if it has a cookie, if it has the user if it has an active session cookie that is not expired, that is still valid, why don't you just send me the access token and the ID token, whatever the user needs to authenticate. And this will work because we have that session cookie on that isolated domain, and we can it's going to send this data back, in that iframe, and we'll have to use, the post data HTML5 API to basically push that access token and ID token from the iframe up to our main frame and be able to store it in memory again so that we can reuse it and have those tokens available in our single page application. Once we do that, we'll have our tokens back and we can make new requests and responses. So every single time the page does get refreshed or does get reloaded in some way, you're going to be making this extra call to your authorization server to get new tokens. Those old tokens, they're just going to be wiped from memory, but that doesn't mean that those tokens are still technically valid, but they just don't exist anymore. So it kind of mitigates the risk of a malicious party being able to steal them and use them. Let's see, what else do we have here in silent authentication? Yeah, I think that covered the big aspects of it. Any questions?
How are you going to distinguish which client is calling that cookie or associate the call from a clean or refreshed browser to the server, authentication server?
Sure. So the question was, how would you be able to distinguish that the call came from your client and not a malicious one?
Or another person.
Or another person, sure. So the way that it works is, in your Chrome browser, for example, once you're authenticated on the authorization server, we set that cookie just for your user. And if you're in that same Chrome browser and you refresh the page and we make this iframe request, it's going to talk to that authorization server domain. So that session cookie is going to be used as the identifier for the user. And if you were to log in again, with a different user, then this cookie would get updated to be a different cookie. So you couldn't get two different users, or you couldn't impersonate. You couldn't make this iframe call from a different domain that would allow you to kind of steal that user's credentials.
So you will store in that cookie data like IP and domain.
Yep. You can store it in that cookie, or you don't have to store it in the cookie, but that cookie can have information for your database that'll have the correct information. Mm-hmm. And also what else you can do is, from your single page application, when you make that iframe request, in the parameters you can identify the domain, the client ID, and the information about the specific app that'll have to be matched up with that cookie.
Yeah, okay.
So the only difference between this and the previous one is that the storage of the token is a little more obscured.
So yes, so instead of storing the token in local storage or somewhere where it can persist and be accessible. Here we're just storing it in a local memory that gets wiped as soon as you refresh the page. And that greatly limits, it still doesn't, it's not a foolproof, 100% secure solution, but is much better than just having the token persisted in local storage or a cookie.
Yeah, I was just going to ask, like, it seems like you're exchanging storage of the token for storage of cookie, right? But is that inherently safer or more secure?
So it's more secure in the sense that it lowers the attack vector. So if your token is persisted either in local storage or in a cookie, it lives there. If a malicious user can kind of identify your domain as having these tokens, if they can breach into it, then making a call to local storage, .get item, JSON Web Token, it's really easy because JavaScript has access to it. But if you store it in your single page application where you kind of obscure it a little bit and make it harder to get into, if it's a very targeted attack and the infiltrator really has studied your domain and figured out where your token is stored in memory, they could do it. But most of these types of attacks are typically really broad, just trying to go into local storage and extract tokens. So it's a little bit safer, but it's not a 100% foolproof plan where they can't gain access to your tokens.
Because can't they just get the cookie though, and then make this?
So they would have to breach your authorization server to get that cookie. And
the cookie's stored on the browser, right?
It's stored in the browser on the authorization server domain. So it's not in your app. Yep, it doesn't run any code. It doesn't have. So if your authorization server gets breached, then you have a whole set of other problems. But it doesn't affect your single page application.
So you're saying to use in memory or iframe, but you're really saying to use the most obscure location that other people aren't using.
Yep.
Is the ideal scenario.
Does this workflow also, is it similar to like single sign-on? Is it like a similar?
It is. So if you did have the authorization server as kind of on a different domain, and in that case, implementing single sign-on would be really simple. You would just authenticate different clients and kind of just whitelist them to be able to talk to the authorization server and give you access. So if you were to kind of separate your authorization server from your traditional application, it would make SSO much simpler down the line. Cool. So, and then I did say I was going to talk about the best current practices, but we'll get to that after the native, because the new code flow that the BCP is recommending for single page applications is this authorization code with the proof key for code exchange grant flow. And traditionally, this authentication flow has been used mainly in Android, iOS, desktop, Chrome extensions, and those types of native applications that that developers build. And the reason for this is these applications or these frameworks and ecosystems have varying levels of kind of public access, where some of them might be a little bit more secure, some of them might expose different sandboxes, expose different levels of access. So PKC, auth code with PKC kind of tries to tackle those different use cases and scenarios a bit more securely than just the authorization code flow, and we'll see why. So to establish our baseline, we have an API, so our API that holds our resources, our business logic, and then we have our native application, and again, this could be an iOS native, an Android application, an Ionic application, basically, any type of native application. So we make requests to our backend API. Our backend API serves JSON responses, or if we, that's pretty much the simple explanation. For our baseline, for our authentication flow, it looks very similar to the authorization code, where when we go to authenticate our user, when we go to log our user in, we hit the login button, get redirected to a login page on our authorization server where we put in our credentials. The big difference here, though, is in addition to passing our client information to tell us where to call back after the user's authenticated, we also attach this additional opaque string of characters called a code challenge. And this is basically a hash function, a cryptographic function that we can generate either in our desktop, in our native language, or there's a whole bunch of different SDKs that kind of do this for us. You should never roll your own crypto or try to do your own hashing stuff. So there's SDKs to do this for you. But basically, in addition to sending your user to log in, you also send a code challenge with that authentication request. The user gets authenticated, verified. If they are good, they get the authorization code that they would expect. So they get 1, 2, 3. And now the second part of the authentication process is to exchange that code. As we've seen in the authorization code example, we send that code back saying, hey, this user's logged in, this user just logged in, they got this code, is this code valid, and can you issue them access tokens? But in addition to that, we also send a code verifier that, again, is another cryptographic function that runs based on the code challenge that we sent earlier. So all of the code verifier and the code challenge both happen on your device or within your Chrome extension sandbox. They get sent to the authorization server. The authorization server verifies both the code and the code verifier to make sure that they are both correct. And if they are, you get your access tokens, you get your refresh tokens, you get your ID tokens. And then once you're authenticated, you can make those requests to your API with the access token. And with the auth code with Pixie or proof key for code exchange, you can also ask for a refresh token, where you couldn't do that in a single page application, because there's no secure sandbox where you can store that refresh token. So that works, and so that's kind of how we do native authentication. And before I get into the single page application with this flow, do you guys have any questions? Cool. Yeah, the auth code with Pixie is basically the same thing as the auth code flow. It just has that code challenge and code verifier that gets sent and verified. And the reason for that is, desktop requests or requests coming from an iOS application have a bigger attack vector where they can be intercepted and modified and changed and looked at. So with that code challenge and code verifier, it kind of helps mitigate some of those. And so the OpenID working group last December came out with a new best current practices recommendation for developers building single page applications. And initially they said that you must not ever use implicit flow again, because it has a bunch of these flaws. You have these tokens that get sent. One of the big issues is when you log in, and here I'll just go back so that we can kind of look at them. When you go and log into or try to log in to your single page application, you go to the authorization server, provide your credentials, and you get your access token and ID token. And these tokens get sent back in that callback URL. So they are appended in the query string parameters. So it'll say something like, myapp.com/callback, and then the query string of access token, ID token, and other information. And having those in the URL is a problem, because different logging software can log the access token. So if your logs get hacked, then you just expose a bunch of access tokens. Other third-party integrations like Google Analytics that also track your query string parameters can also capture those tokens, and other types of code that might be running in your application. So having the access token and ID token in the query string is problematic. So what they recommended is to use the auth code with Pixie, so that we can have a better experience and a much more secure experience in issuing the tokens, because they would be delivered then in the body of the request rather than the query strings after that code verifier has worked. And the implicit flow was implemented or recommended way back like 8 to 10 years ago, where we didn't have cores, we didn't have all of the niceties that we have today. So implicit flow still works, and the BCP was changed once everybody kind of freaked out and said, holy crap, now I need to change all of my single page applications. This is a really big problem. So they kind of walked it back and said you shouldn't use the implicit flow if you're happy with your applications at the moment. If you're happy with, if you've kind of evaluated the risk factors of having those tokens in the URL and you have ways to mitigate that, and you're not so concerned with it, then keep using implicit flow, and people are going to keep doing it for years and years. But we do support auth code with Pixie now for single page applications, and third-party companies like Auth0, like Okta, like Microsoft and AWS, they're already updating their SDKs to support auth code with Pixie if you wanted to follow the best practices. But the implicit flow is still going to be used for many years to come. So it's not a the sky's falling. Don't go and change your code on a Friday and push the update. So that's really the big change there. So just to summarize really quickly, and then I'll take any questions. Modern authentication is complex. So OAuth, OpenID Connect, JSON Web Tokens, all of these open standards, were created and developed to kind of help us standardize the way we do authentication. We do delegated access, but they've introduced a whole lot of complexity to how we do it, and sometimes it might seem over-engineered or much more complicated, but there are good reasons for it. OAuth 2.0 offers solutions, flows for most use cases. So whether you're building a SPA or a traditional web application or a native application or some type of hybrid in between, there is a flow for you. So whether it's web API, single page app, or native. And then implementing OAuth can provide you a competitive advantage. So like somebody mentioned, if you wanted to add single sign-on down the line, if you have your own authorization server, you're 90% of the way there. Then it just becomes a matter of authenticating additional clients. If you wanted to add additional security features to your authorization server, like multi-factor authentication or anomaly detection or any other enhanced features, all your code changes would be on that authorization server, and your app is really kind of independent. So your app doesn't care how your users authenticate, what it takes for them to to be authenticated in the app, but once they are, then they can have access to those protected resources, and your authorization server becomes kind of the entity that figures out how to authenticate that user, what steps they need to take to be authenticated and verified. And then just a couple of additional resources if you guys are interested in learning more about OAuth. The official website has kind of a lot of information on the spec, how it works. But if you wanted a more user-friendly, kind of a beginner guide on OAuth, this bit.ly link, OAuth Complete Guide, was written by one of my colleagues at Auth0. It kind of walks you step by step on what it means to implement an OAuth server and how to do it in Node.js, I believe. And then finally, this last resource is OAuth 2.0 scopes. And this deals with scopes and permissions. So once you have your user authenticated, how do you give them the right permission at the right time? How do you change those permissions? And it just goes into what scopes are meant for, what they're not meant for, and some strategies there. And with that, I do want to say thank you guys. You've been really great, and I'll be around for the next 5 minutes to take questions, and then outside if you guys have any additional ones. Thank you.